Hello students. So today the discussion is about resistance and parameter, means with parameter variation. So resistance with parameter variation, just for example, I'm taking one conductor, like for this conductor, this is the cross sectional area. Okay. So through this cross sectional area, with respect to length, resistivity is changing. So let it be, its length is what? This is the length of this conductor is what? L. Okay. So if you take about with respect to this, resistivity changing. Okay. So resistivity rho is changing. Rho is changing with respect to x distance. For example, at this position x is equals to 0. So for example, if it is changing as a function of x, for example, this I'm choosing about, this is the length element. The length element is, this length element is called as a elemental resistance. Elemental resistance. Okay. So this is what elemental resistance. So now we can see elemental resistance is what? It's a dr. Elemental resistance is what? Dr. Total resistance is what? R. So whenever this potential difference is created, okay, it's what? For example, this is x and y, you choose about it. So from here, with respect to length, resistivity is changing. So what's my intention? What I'm going to do on this? So this is divided into the infinite parts. Infinite parts perpendicular to its length, because resistivity is changing along with this. Okay. So when you divide into the infinite parts, then if you want to add all the parts, each one is one resistance. So one is one resistor means what? All of them connected in series, like. So connected in series means dr is equals to, what do you say, r1 plus r2 plus r3 plus, like this. So next concept I'll do that, if it is resistivity is changing, so it's what? Like this one along with y axis. So all the which are cut into the infinite parts, those will be in what? Parallel combination. Okay. So here now just my discussion is about, so whenever if I talk about this, resistivity is changing. Okay. Resistivity is changing. Rho is equals to rho naught as a function of x. Let it be this. Okay. So elemental resistance is what? Elemental resistance. So the elemental resistance dr is equals to, okay, dr is equals to, then what is the condition? Rho. So what is the r? R is equals to rho into L by A. Okay. Rho. So as a function of x, this is what? Rho. Next one, what length is this? This length I am choosing as, it's a x. This length from here to here, it's a, this is a dx is the length element, it is what? X. So rho. And next one, L is what? It's a dx, right? Its length, this part is what? Dx. And next one, cross sectional area is not changing, it's a. So now R total, if you take about, all these elements are connected in what? Series combination. So series combination means what? R series means what? R1 plus R2 plus R3. That means what? Integration. Okay. Integration over dr is equals to integration over rho of x dx. Okay. By A, cross sectional area. So its limits from where? So the limits from 0 to L we can take on this. So this is the method of problem solving based on such type of questions. If I use about, for example, a linearly changing, so rho, it's a rho of x is equals to, rho of x is equals to, so for example, if I say a plus b x square, let it be this. Linearly changing, it's what? A plus bx square. Rho, resistivity is measured in terms of what? Ampere meter. So this R total is equals to, R total is equals to integration over, so rho of x means what? It's a plus bx square. So next dx by A. A is the cross-sectional area. Its length is what? 0 to L. So we will go for the proper integration to get total resistance. Okay. So just for calculation, R total is equals to A. So okay, this is what A na. I'm choosing for our convenient. This is what? Small letter A, small letter B. It's a small letter A and B I'm choosing because this will be cancelled na. So A and B. So this what? 1 by A is outside. Integration 0 to L A dx plus integration over bx square dx 0 to L. Okay. So R total is equals to 1 by A times. This is 1 by A times. So A integration over dx is what? X. Limits from 0 to L is what? It's a L plus B x cube. X square means what? X cube by 3. X cube by 3 means it's a L cube by 3. So is your relation. So here when resistivity rho is changing as a function of x with respect to length means what? You are dividing into the infinite parts. These infinite parts all will be in series combination. R total is equals to, so R1 plus R2 plus means what? Integration over dr. So like whatever the function is given, we can substitute. So here if resistivity is changing perpendicular to length, before slide we discussed about resistivity changes parallel to its, means what? Along with its length, now perpendicular to its length. Just this is the conductor. Okay, so there are the two terminals, positive and negative. Yes. So if it is divided, means what? The resistivity is changing perpendicular to its length. Perpendicular to its length is resistivity is changing from here. Body like a three-dimensional. If you take on this is the body. Okay. So now it's I want to choose about elemental resistance, length element. So that's what. First of all, its length is L. This is the length of conductor. So when I'm choosing this is the elemental resistance. Okay. So this is the elemental. A small strip is divided. Small strip is divided like this. Yes. So like I cut this one like along with y-axis. So resistivity as changing as a function of y. It's a rho. Okay. So this thickness is what? Its thickness is dy. Okay. Along with the y-axis. Correct. And what is the area of this? For example, its width is w I'm taking. Yes. So this is what it's a dy. Now its area A is equals to w into dy. Yes. W into dy. So what is the length? So actually from where to where? This is L, but it is changing with respect to this point. So its length is what you say? Length is equals to its what? Y. Okay. So now we can talk about dr, elemental resistance. Dr is equals to, okay. So dr is equals to rho into, yes, rho as a function of y. Okay. Rho. So because dr is equals to rho into L by A. L means what? Length. Rho. L means what is this? Y by A. A is, it's a W into dy. Okay. So now from this I'm talking about, this is total resistance. Total resistance is, so it's a 1 by R total. 1 by R total. 1 by why 1 by R total? All these connected in what? Parallel. These two are the terminals. Okay. So from between these two terminals, these are connected in what? It's in a parallel. So 1 by R total is equals to 1 by, okay. So it's what? Integration over dr. Yes. So it's a 1 by R total is equals to, So this is integration over 1 by r, okay, 1 by dr. What is a dr here? This. So it becomes reciprocal, means what? Rho y by w dy. It means w dy by rho y. Okay. So now this, from here we can write this is 1 by r total is equals to, so integration, it's correct, it's an integration, right? So this is what integration. Now integration over w dy by rho y, limits from where? 0 to y is the condition. So when resistivity is changing with respect to y axis.